Continuing with 11.3, in the last video we saw how to apply the integral test, or what an integral test is, and how we can use it to check the convergence and or divergence of a series. And then in the end we notice there are some kind of series that are hard to apply the integral test. So, and other tests that we have learned, or other types of series, they also don't conform with those, so we need new tests. So the next test is what we call the p-series. So p-series test. So what is a p-series? Well, a p-series is a simple, very simple series, something looking like this. So where p is a real number, okay, and we are going to say that p is positive. So because if p is negative, then you notice this can, if p is, for example, -2, we can write it as n squared. So summation, this will become, and that is almost always divergent. So if you think of your integral test applying to this one, which we can actually do, so it will look like something like this. And from section 7.8, when we introduced the improper integrals, if you recall, we found that this converges if the value of p is greater than 1, and it diverges when p is less than or equal to 1. So not only just greater than 0, but it has to be greater than 1. And so some of p-series are written over here, some examples of p-series. So notice here it's always going to be 1 over n raised to a number, and the number has to be positive. Notice here you can also have something like summation 5 over n to the 2. That can also be considered as a p-series, because you can always write it as 5 times 1 over n squared, and so on. So we say, what is the p-series test now? It is based on this integral which we saw in section 7.8. We say that a series, like the series, first you have to identify it's a p-series. So if a p-series, something like this, converges if p is greater than 1, and it diverges if p is less than or equal to 1. So when you have a p-series, what you need to look at and do is write your p. So you can see here, this is p-series. P is equal to 2, which is greater than 1, so converges by p-series test. Always remember, must mention the test. So always must mention the name of the test, otherwise you will lose some points. Okay, looking at the next one, if you notice, this is, by the way, this is something we already remember in the last video. We proved it by using the integral test, that this is converges. But now you notice that with this kind of series, you don't need to spend time doing the integral test. You can actually use the p-series test. Again, the next one, notice, is, what is it? This is actually the harmonic series, and we already know that it diverges. But here now you can use the p-series. So you can say p is equal to 1. So this diverges by p-series test. So we are not performing any action, we are just stating what p is. So in this case, p is 1/2, which is less than 1. So this again diverges by p-series test. So if you notice here, this is kind of very simple thing. So In this case, P is 2 over 3, which is less than 1, so which means it diverges by P series test. So the P series actually you will not get a question where you are given a P series and you are asked to check convergence or divergence, but this comes in very handy with other tests, which you will notice in the coming videos.